Hello everyone. So this is part 2 of how do I solve by completing the square. So we've taken a look at what it means visually to complete a square. Keep that picture in your mind because we're going to need that as part of our process today. So you've written this key question in your notes. After that, we're going to go ahead and start some examples. So the process of completing the square, sometimes I abbreviate it as CTS. Let's take that example, x squared plus 4x plus 1. How do we solve this problem if we can't factor it and we can't take a square root? Well, what we'd want to do is create a process where we can fill in the blank like you do visually with that completing the square picture. So the first step in my process is going to be to go ahead and create a space for the blank. Right now there's a 1 right here. I don't want him here. I'm going to go ahead and subtract him away. And then I'll have x squared plus 4x plus room for the blank, and over here negative 1. So this looks similar to what we were doing visually back on that last video. So if I had to fill in the blank, what number would I use to fill it in? Well, remember what we were thinking about? If I had x squared plus 4x's, I would stack those x's 2 by 2, therefore creating a space of 4 that needs to be filled in. So I'm going to fill in the blank with the 4 that comes from taking half of this, which is 2, and taking 2 times itself, or 2 squared. So 4 gets filled into that blank. Now, since I added a random 4 there, I can't forget to add 4 to the other side. If I only add it to one side, it throws off the whole equation business. I need to be sure that I'm consistent. So once I've done that, I'm going to go ahead now and start to simplify my process here. X squared plus 4x plus the 4 I added, and over here negative 1 plus 4 is 3. Now on this side over here, I need to go ahead and factor. So I want you to think about what multiplies to make 4, that's the A times C, and adds to make 4 in the middle. Well, that's 2. 2 and 2. So if I factor it, x squared plus 2x plus 2x plus 4, using my squares here to sort of help me factor, I get x plus 2, x plus 2 as my two factors. Now, since I have x plus 2 times x plus 2, a short way of writing that is just saying x plus 2, it's really being multiplied by himself. It's squared. And by doing that, I now have a way that I can free up that x so I can solve. I can now take this and square root it. So I end up with x plus 2 on this side, and on this side I get that plus or minus square root of 3. And x is almost alone now, so now I go ahead and subtract the 2. X equals negative 2 plus or minus the square root of 3. So the process of completing the square finds me those two solutions. One of them is negative 2 plus the square root of 3. The other one is negative 2 minus the square root of 3. Both of those are irrational decimal sort of answers that we don't need to write out. We'll just leave our final answer like that. But I still have my two solutions thanks to completing the square. Okay, let's take a look at another example. Another example, x squared minus 12x plus 4. Same idea. First thing we need to do is make room for the blank. We need to subtract that 4 over. X squared minus 12x plus whatever is going to fill in the blank. And on this side, there'd be a negative 4. Well, what do we do to fill in the blank? Think about having x squared minus 12x. Think about that visual. We'd split that 12x in half. Negative 6 by negative 6, negative 6 times negative 6 is positive 36. So I'd add 36 to both sides. Don't forget to add it to the other side. Now over here, negative 4 plus 36 is 32. And on this side, I'd have x squared minus 12x plus 36. At this point, now I want to go ahead and factor. Using the AC method, 1 times 36 is 36. What multiplies to make 36 and adds to make negative 12? That'd be negative 6 and negative 6. So I'll go ahead and place them in our 4 squares here to help us factor. So I end up with x minus 6 times x minus 6. And the other side's still 32. Now, like that last example, when you have x minus 6 times x minus 6, that's the same thing as saying x minus 6 squared. Yes, that should always happen. You should always end up having something squared. That's why we're completing the square. Okay, so 36 is still happening on, or 32 is happening on the other side. So now we'll go ahead and square root to free up the x minus 6. Now over here, the square root of 32 is 16 times 2. So this is 4 square roots of 2 with a plus or minus in front. And now when I go ahead and bring my x minus 6, I'm going to add the 6 over. X equals 6 plus or minus 4 square roots of 2. Done. Final answer. Okay, one last example. What if there's a number in front of the x squared like this? The last ones were so easy, and now I have 2x squared. Well, first thing I would do, since all of these can be divided by 2, let's do that. Let's divide everything on both sides by 2. Make this problem look a little nicer. And now once I've done that, I start that completing the square process. Subtract the 7 over to leave room for the blank. Now fill in the blank. Half of 4 is 2. 2 times itself is 4. Filling in the blank with 4. This then becomes factorable. What multiplies to make 4 and adds to make 4? We've already done this one. 2x, 2x. So if I factor him, this turns into x plus 2 times x plus 2, and the other side is negative 3. Yep, this is x plus 2 squared, and I have negative 3. I'm going to go ahead and square root him. X plus 2. On this side, remember that whole negative in a square root? This is going to be plus or minus I square root of 3. And now when I bring my 2 over, when I subtract them, it's x equals negative 2 plus or minus I square root of 3. Here's my final 2 solutions using the process called completing the square. So we'll work more on this over the next couple days, but hopefully you get the basic idea. Thanks.